Jet hard computing versus soft computing. What is the concept of soft computing, especially tools of soft computing that already we discussed? They are called fuzzy logic, neural networks, generic algorithms, machine learning, probabilistic reasoning. Okay. Importance of soft computing. Importance of soft computing. Concept of soft computing. Future scope of soft computing. Future scope of soft computing. These you must know. Let us we go to that our part. Last class we discussed about the special networks. We discussed last class optical neural networks and electro-optical amplifiers, holographic correlators, electro-optical multipliers, and also third generation neural networks, spiking neural networks, architecture of SNN model, now we will discuss one of the neural model. That neural model is based on the equations. Just observe the equations. I will share that presentation to you. This is the neuron model. The parameter A describes in this the time scale of recovery variable U. Smaller value result is slower recovery. A typical value A is equal to 0.02. The parameter B describes sensitivity of the recovery variable U to the subthreshold fluctuations of members of potential B. A typical value is B. Parameter C describes after spike set the reset value of the membranes. Parameter D describes a spike reset of recovery variable. Like that, those parameters are there. The model is a two-dimensional differential equation to represent the state of single neuron I namely the membrane's recovery variable U of I and membrane's potential V of I. U of I less belongs as a hard reset spike. Additional four parameters are used for configuration of neurons, a time scale, sensitivity, encoding of neuron. Spiking neural network can encode digital and analog information. The neural coding schemes are of three categories: rate coding, temporal coding, and population coding. In rate coding, the information is encoded into the mean of firing rate of the neuron, which is also known as temporal average. In temporal coding, number of input neurons are involved in the analog encoding, and this produces different firing times. Commonly used encoding method is the population based encoding. In population based encoding, analog input values are represented into spike times using population coding. Multiple Gaussian repetitive fields are used that the input neuron encode an input value of the spike times. The firing time is composed based on the insertion of Gaussian function. The center of Gaussian function is calculated using the following formula. You can observe nu value and sigma value here. The parameter beta controls width of the each Gaussian receptive field. Learning with a spiking neuron. Similar to the supervised training algorithms, the synaptic weights of the network are adjusted iteratively in order to impose a desired input-output mapping. To the supervised learning, learning is performed through the implementation of synaptic plasticity and excitatory synapses. The synaptic weights of the model, which are directly connected to the input pattern, determine the firing rate of the neuron. This means that carried learning phase generates desired behavior by adjusting the synaptic weight of the neuron. The neurons characterize sudden change of the membrane potential instantaneously prior to the subsequent to the firing. Commonly in training SNNs, some of the learning models include spike-based supervising, Evin learning, RESC, UME, and spike time dependent plasticity. Neurons can be trained to classify categories of input signals based on the temporal configuration of spikes. The decision is communicated by emitting precisely timed spike times associated with given input categories. Trained neurons can perform the classification task correctly. The weights between presymptomatic neuron and postsymptomatic neuron, presymptomatic neuron marked as I, and post-supramatic neuron is marked as J, do not have fixed values. It has been proved through experiments that they change, and this affects the amplitude of the generated spike. The procedure of the weight update is called learning process, and it can be divided into two categories: supervised and unsupervised learning. If cinematic strength is increased, then it is called long-term potentiation. The strength is decreased, it is called long-term depression. These two are technical words I am posting. One technical word, other technical word. Spike probe learning algorithm. Neurons are as computational units which account to precise firing times of the neuron for information coding. The information retrieval from the spike trains neurons encoded the information are done by binary bit coding, which is a population coding approach. The section presents error back propagation supervised learning algorithm and employed spiking neural networks. Each SNN consists of a set of neurons, input neurons, output neurons. Each non-input neuron with the threshold function. The structure of neurons tend to fully connected feed-forward neural network. The source neuron will fire and propagate spikes along all directions. Formally, a spike train is defined as a sequence of pulses. Each target neuron receives a spike, experiences an increasing potential at a time. The firing time neuron is defined the number of the spike. The objective of the set of target firing times, actual firing time. Error propagation algorithm. See these mathematical logics very clearly. The basic weight adoption functions for neurons in the output layer, hidden layer are given by these functions. These mathematical equations are responsible for this concept. This is the concept. Okay? Weight propagation function for the neuron in the output layer, hidden layer. It's represented tau, delta, W like that. The training process involves modifying the threshold of neuron firing and synaptic weights. The algorithm steps involved in learning through spike prop. The spike prop algorithm, step 1, the threshold is chosen and the weights are initialized randomly between 0 and 1. In feed forward stage, each input synapse receives input signal and transmit to the next neuron. Hidden units. Each hidden unit with a SNN function calculated is sent to the output unit, which is in return calculates the spike function as a response for the given input. The firing time of a neuron is found. The time to first spike of the output neurons is compared with the desired time of the first spike. Perform error propagation learning process for all layers. The equation are transformed to partial derivatives and process is carried out. Calculate dow J using actual desired firing time of each output neuron. Step 5. Calculate dow I employing the actual and desired firing times of each hidden neuron. Step 6. Update weights for output layer. Calculate each change in weight. Step 7. Compute new weight delta W. For hidden layer, calculate each change in weight. Step 9. Compute new weights for hidden layer. New weight is equal to old weight plus delta W. Spike time dependency plasticity algorithm. This is the algorithm. Spike time dependent plasticity is viewed as a more quantitative form of Hebbian learning. It emphasizes the importance of causality in synaptic strengthening or weakening. STDP is a form of Hebbian learning. Spike time and transmission are used undertake to calculate the change in synaptic weight of the neuron. When the presynaptic spike proceeds, postsynaptic spikes by tens of milliseconds, synaptic efficiency is increased. When the post-synaptic spikes precede the presynaptic spikes, the synaptic strength decreases. Furthermore, synaptic efficiency is found of the spike times of the presynaptic and postsynaptic neurons. This is called spike timing dependent. The well-known STDP algorithm modifies synaptic weights using following algorithm. STDP algorithm can be used in inhibitory or exhibitory neurons. This is a very important one. Please see this, I am posting this concept. So it is a typo check HTTP. HTTP learning can be used as inhibitory or exhibitory neurons. Convolution and neural network. Next concept is convolution neural network. This convolution neural network is built up one or more number of convolution layers, and after then it is trailed by one or more fully connected layers like feed forward networks. CNN architecture is designed to possess the structure of two-dimensional input image. That is a key advantage. Input consists of images, and this representation of images design the architecture in the physical way. The neurons arranged in three-dimensional height, depth, width, and depth. The information pertaining to depth is an activation volume, and it represents third dimension. This architecture design of CNN is carried out with the local connections and possesses weights, which are subsequently followed by certain pooling operations. CNNs can be trained in the easy way manner, and these have minimal parameters for the same number of hidden units than that of other fully neural networks. Consider for comparison. Figure shows the arrangements of neurons in three dimensions in a convolution neural network. As a regular neural network, the convolution neural network is also made up of layers. Each and every layer transforms an input 3D volume to an output 3D volume along with certain differentiable activation functions, with or without any parameters. Layers in convolution neural networks. It is well noted that convolution neural network is a sequence of layers, and each and every layer in convolution neural network perform transformation of one volume activation to the other by employing a differential function. CNN consists of three major layers: convolution layer, pooling layer, fully interconnected layer. These layers between the input and output layer. Input layer holds the input values represented by the pixel values of an image. Convolutional layer perform computation and determines output of a neuron that is connected to local region to the input. The computation is done by performing dot product between their weights and a small region, and if connected to the input value. After then, an element-wise activation function is applied where threshold set to 0. Applying the activation function results change in size. Change in after then element activation function applied where threshold set to 0. Applying activation function result no change in size in the volume of the layers. Pooling layer carries out down sampling region along with spatial dimensions including width and height. Regularly fully connected layers perform computational of class course belongs to the class or not and result in a specified volume size. In this manner, convolutional neural networks transform the original input layer by laser and result in a final scores. Pooling layer is implemented only by function. Pooling layer is implemented with a spatial dimensions including with weight, height. Regularly fully connected layers perform computational class stores. Volume size. In this manner, convolutional neural networks transform original input layer by laser and result in fine scores. This is the concept here. In this manner, the convolution layer on the neural networks transform the original input layer by a laser and result in the final scores. Pooling layer implements only a function, whereas convolutional and fully interconnected layer implements the function, where convolutional and fully interconnected layer implements transformation on function and as well as weights of the biases of the neuron. Fundamentally, a convolutional neural network is comprising a sequence of layers transform the image volume output into output volume. Each of the design layer is modified to take an input volume data and perform transformation to the output three-dimensional data employing a differentiable function. The design convolution and fully interconnected layers possesses parameters and pooling layers do not possess parameter. Pooling layer do not possess parameter. Architecture of convolution neural network. It is well known CNN is made up of number of convolutional and pooling and also called as subsampling layers, subsequently followed by fully interconnected layers. In certain cases, this layer becomes optional based on the application considered. The input presented to the convolution layer and is the height, width of an image Pre refers to the number of channels. Designing layers in convolution neural networks. Designing of convolution layer. The primary building block of convolution neural network is the convolutional layer. The convolution layer is designed to perform intense computations. In this convolution neural model, the convolution layer possesses set of trainable filters, and every filter is specially small but noted to extend through the fullest depth of the input volume. When the forward passes get initiated, each filter sights across the height width of the input volume, and the dot product is composite between the input and position and that of the entries in the filter. And the filter sights across the height and weight of the input volume. A two-dimensional activities future map is a produced that give a responses of that filter at a very special position. The filter got activated when they come across certain types of visual features like edge detection, color strain on the first layer, certain specific patterns. Neurons learns from their filter and gets activated. In CNN network model, the convolution layer, each neuron gets connected only to a local region of input volume. Special event of this neuron connectivity is represented by a hyperparameter called receptive field of the neuron. It's a technical word. The receptive field of the neuron is filter size. The spatial extends connectivity along with the depth axis will be equal to the depths of input volume. These connections tend to local in space and get full towards the entire depth of the input volume. With respect to number of neurons, the output volume, these hyperparameters are noted to control the size of the output volume, depth, stride and zero padding. The depth of the output volume refers to the number of filters to be used, where each learning searches the existence of difference in the input. The stripe is specified for sliding the filter. The movement of the filter is specified by the equations of the above. A time is required to input volume with zeros around the border. Hence, other hyper parameter size of the zero padding. Zero padding allows controlling the spatial size and output volumes. It should be noted that neurons presented in the single depth employ same weight vector and every depth slice for forward passes convolution layer can be computed as a convolution of the neuron weights in the input volume. The sets of weights are referred to CNN filter and gets convolved with input. The limitation of this approach is it uses lots of memory limitations, and certain values of input volumes are repeatedly for the multiple times. This is a limitation here. Okay. It is to be noted that backward pass for a convolution operation is also a convolution process. The backward pass also moves to the back propagation neural network. In few works carried out earlier, it is observed that one-by-one convolution, but for two-dimensional case is similar to a point-wise scaling operation, as this convolution model is operated move on three-dimensional volumes. And also filters get extended over full depth of input volume. It is to be noted that employing one-by-one convolution will perform the three-dimensional dot product. Another method of convolution is the dilated convolution, where the added hyperparameter called dilation is included in the convolution layer. In case of the dilated convolution, there is possibility to have filters with space between each cell. Implementation will be in a manner of dilation, zero dilation. Gap 1 will be adopted between the filters, and so on. Employing dilated convolution increases the receptive field. To design a pooling layer, pooling layer between the successive convolution layers, pooling layers are placed. The presence of pooling layers between convolution layers to gradually decrease the spiritual size of parameters and reduce the computation in the network. This placement of pooling layer also controls the occurrence of fitting. The pooling layer works independently on depth of slice of the input as well as the resizes them specially. Commonly employed pooling layer is the one with filter size of 2x2 applied. Okay? Straight two down samples. The two down occurs for every depth of slice. Input by along with height and width. Okay? The dimension of the depth parameter retains unaltered in this case. Pooling size height, higher receptive fields are noted damaging, generally used for pooling mechanism for max pooling. Apart from these operations, the pooling layer can perform functions like mean pooling, the backward process of pooling layer. The process is only to route gradient to the input, that possesses the highest value in the forward pass. Hence, at the time of forward pass of the pooling layer, it is important to track index of the activation function so that the gradient rotating carried out effectively by a back propagation network algorithm. Okay. Layer modeling, CNN and common CNN nets. The other layers of importance of convolution neural networks are the authorization layer and fully connected layer. Neurons normalization layers are deployed to be CNN model, and they are designed in a manner to implement the inhibition procedure of human brain. Various types of memorization procedures like mean scaling, max scaling, summation process, etc. can be employed if required the operation in CNN model. Fully connected layers process fully interconnection for all activation previous layer. As a regular, their activations are based on computing the net to the neurons of a layer along with the brains of the input also. Convolution fully connected layer to the convolution layer. Main difference between fully connected and convolution layer is that neurons present in the convolution layer get connected only local region. In input and the neurons is convolution voluminous structure is share their parameters. Just I will post this concept. The neurons, both fully connected and convolution layers, calculate dot products. Hence, the functional from neurons is the same. Therefore, it is possible to perform conversion between fully connected and convolution layers. Okay, this is a concept. Considering any convolution layer, there exists a fully connected layer which implements one and the same forward pass function. Weight matrix will be a large and one and possesses zero entities. Concept at specific blocks. No self connection and existence of local connectivity. And the weights numerous blocks tend to be equal. Fully connected layer can be converted into convolution layer. Here the filter size will be equal to the size of the input volume and the output will be single depth column fit across the input volumes. This gives the same result of that initially fully connected layer. In both of these conversions process, converting a fully connected layer to convolution layer generally in practice. Fully connected layer and convolution layer, that is the difference I highlighted. The remaining interesting points we will discuss in the next presentation. Okay, just try to understand about fully connected layer and convolution layer concepts. Okay, right. Thank you all. Okay, I want to stop my screen. You understand about my concepts I posted. ప్రతిదాన్ని మీకు పోస్ట్ చేస్తూ వచ్చానండి ఈజీ వేలో. ఆ ప్రతి కాన్సెప్ట్ని ఈజీగా చూడండి. Try to interpret and analyze those concepts. Okay, right. Thank you.